Good morning to you. Good morning. We are in 6.3. Doing trig. You finished up 6.2, I hope. Trigonometry going okay? So we're into the properties today. Properties of trig functions. I think I wrote this, did I? I can't remember. Up yesterday. Remember the periods of the trig functions? So I did, right? I said that yesterday. Tangent and cotangent, their periods are pi. So what that means is every pi, or, pi is the same as 180 degrees, they repeat. Every pi or 180. I forgot my pencil on the right of my finger today. Oh, that would help. So every pi or 180 tangent and cotangent are going to repeat. And how about the other ones? The other four? 2 pi. Sine, cosine, and secant and cosecant. Their periods. Come on. Okay, come on. Periods are 2 pi or 360. All right, so what does that mean? So that means every 180 tangent, this is tangent or cotangent, so cotangent is going to repeat itself every 180 degrees. So that means you can add 180 and it'll be the same thing, or subtract 180 and you get the same value, right? So I can take the cotan of 390. First off, and I can take 390 and just subtract 360 and get 30 degrees, right? So the cotan of 30 degrees is going to be the same as the cotan of 390. Does that make sense? Because it's just a full 360 circle and 30 more. So really, when they say cotan of 390, it's just going to be cotan of 30. Now, okay, what is the cotan? They want the exact value, no calculator, same kind of thing as yesterday. So I've got to find the cotan of 30. So what am I going to do? Yeah, do 1 over the tangent, or you can just go right to the definition. I hope you got that down. I just erased it. So that was tan and cotan or pi. The others are 2 pi. So yeah, I'm going to go to the unit circle now. Well, I'm going to say cotan of 30 degrees is cosine of 30 over sine of 30. Right? Because remember, tangent is sine over cosine, cotan is cosine over sine. And so then go to the unit circle. 30 degrees is right there. Right? And so it's over large, up small. It's over the large amount, up the small amount to a 30-degree angle, isn't it? So that means the coordinates of that point, it's over square root of 3 over 2 up a half, isn't it? Remember the small, medium, large that we talked about yesterday? It's root of 1, root of 2, root of 3, over 2. They're all over 2, right? So the small is root of 1 over 2 or a half. The large is root of 3 over 2. So the coordinates then of that point, kind of running out of room, if I could squeeze them in, they're root 3 over 2 comma a half. If you can read that scribble there. So that's the coordinates of that dot. Now so cosine is, remember, the x is cosine, the y is sine. Right? The x value is cosine, the y is sine. So cosine, root 3 over 2 over sine a half. Is that okay? Can you all read that okay? And then you know the deal, bring it up, flip it up. So it's, whoops, doing 2 roots there. So it's root 3 over 2 times 2 over 1. The 2's cancel. Square root 3. So the cotan of 390, same as the cotan of 30. Square root 3. Questions on that? Is that good? This trig, it's all coming back to you? Everybody get this down okay? Did I go too fast over this? Everybody okay with cotan of 30? Right, it's cosine over sine, it's root 3 over 2 over half, flip it out, 2's cancel. Root 3, right, because the point at 30 degrees, 30, 45, 60, 30, is over large up small over root 3 over 2 up a half. Okay. So, yeah, it's going to be 0. Sine of 18 pi is going to be 0. Is everybody good with that right away? Because what is 18 pi is a bunch of 2 pi's, isn't it? Right? 18 pi is 2 pi times 9. It's 9 full rotations, isn't it? It's 9 2 pi's. 2 pi's all the way around. So it's just 9 full rotations. So when you're done with your 9 full rotations, you end up right here. That's supposed to be a dot. Where you started. You end up where you started. What's the coordinates of that point? Over 1 up 0. Remember, cosine is x. Sine is y. We want sine. 0, we're done. Tim.
So when it asks for an even number, it would be 0, but if it's an uneven number, it would be 1.
Yeah, that's right. If they ask for sine of 17 pi, it's either going to be 1 or negative 1, depending on whether we stopped at the top or the bottom. We'd have to count them to be sure. That's right. All right. So let's keep. Okay. So for this, probably the best thing is the all students take calculus, right? Probably the easiest thing to do. Have you heard that thing before? You start in the upper right-hand corner, first quadrant, and then you go counterclockwise. All students take calculus, which is true of you, right? You're among the all. And what does that mean? That means all 6 trig functions are positive in this quadrant. In this quadrant, only sine is positive, and of course his reciprocal, cosecant. And in this quadrant, only tangent is positive, and of course his reciprocal, his upside down, is going to be the same sign, cotan. And in the fourth quadrant, only cosine is positive, and his upside down, secant, of course. So in other words, that's telling us which trig functions are positive in which quadrants, and the other ones are therefore negative in those quadrants. So in the upper right-hand corner, all 6 trig functions are positive up here. All 6. All 6. Sine, cosine, tangent, cotan, secant, cosecant. All 6 are positive in that quadrant. But in the second quadrant, only those 2 are positive. The other 4 are negative. This quadrant, only tan, third quadrant, only tan and cotan are positive. The other 4 are negative. And in the fourth quadrant, only cosine and secant are positive. The other 4 are negative. Okay, let's put that together. They're telling me sine is positive, greater than 0. Tangent is negative, less than 0, right? So which quadrant has sine positive, but tangent not positive? Quadrant 2. Where sine is positive, but the other 4, including tangent, are not positive. They're negative. So we're in quadrant 2. You know the quadrants go, right? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And here's a question you might not have thought about. Why do we use Roman numerals to number the quadrants? Why don't we just go 1, 2, 3, 4? I'm just being silly. There's no real reason. I think it's just they don't want to confuse like numbers on the axis system. One of my favorite far sides, so I'm going to do a joke now if that's okay. Like a 1-minute joke. Try not to use up too much time. But one of my favorite far sides was, you ever thought about doing math in Roman numerals? You know, Roman system was the system, obviously, during the Roman Empire. So, right, so how do you make, let's make some numbers. How do you make 2,000? Anybody know the Roman numeral system? Isn't it 2 M's? Yeah. 2 M's? M, 2,000, let's do 800, no, let's do 900. How do you do 900? Isn't it the C before, no, C's the 100, century, 100, C's 100, and you put like XC, because that's 10 before, anyway, that's 900, we're not doing a Roman thing, good enough. 900 and, I don't know, 80, so 80 would be what? What's 50? D? Is D 50?
No.
Isn't D 50? D's 50, I think. 80. 7. Okay. Take away. You getting the deal, right? 300 and 9.
Can you imagine when you got to borrow?
Yeah, right. So anyway, so they showed this, right? Because I don't know if you ever thought about it. It's not a place value. If you ever looked at the way number systems work, our system is a place value system. Theirs is not place value. In other words, the x way over here is still only worth 10. Wherever you find him, he's only worth 10. He doesn't become more as you move to the left. It's not a place value system. Anyway, I'm not doing a Roman numeral thing here, but it was my favorite Far Side. It showed the Roman guy trying to subtract and borrow, like you were saying, Robert, and then it had a blurb. Another reason Rome fell. All right, we'll move on. All right, so I'll give you a second. Hold it. Don't shout it out. Give everybody a second to try. Find out which quadrant. Use the all students take calculus. Cosecant. Cosecant is the upside down of which one? Sine, huh? So you do have to know that, which ones are upside downs of which ones. So when they say cosecant is positive, they're basically saying sine is positive, huh? And cosine is negative. So which quadrant are we in? Where's sine positive, but again, it's quadrant 2 again. Sine's positive, but cosine's not, right? Quadrant 2. Is that good? That makes sense. All students take calculus. Easy way to do the signs. Because they all come from sine and cosine, right? So they give me sine and they give me cosine. I can find the other 4 because they're all just involving sine and cosine. So tangent, as you know quite well, is sine over cosine. So that would be 2 root 5 over 5 over root 5 over 5. And then you flip it up. So it's 2 root 5 over 5 times, and it flips upside down. 5 over root 5, right? These cancel, these cancel. Oh, it's just 2. So the tangent's just 2. Can I just go dot, dot, dot? You know the rest, right? Cotan's, what's cotan? Yeah, cotan's going to be a half. So now I'm wanting to do them all there. Yeah, cotan's a half because it's the flip of tan, right? There's tan, there's cotan. Right? And then let's do maybe one more. What is cosecant? It's 1 over sine. And so basically it's take your sine and flip it. 5. 1 over means flip it, right? Good to there so far, but I can't leave it that way because I can't leave a root in the bottom, huh? Right? Multiply top and bottom by root 5. Get 5 root 5 over 2 times regular 5. Right? Because these 2 root 5s make a. So number 9. Yeah, so they're telling me I'm in quadrant 2. I'm going to actually draw in quadrant 2 some kind of triangle. Yeah, you're going to have to actually draw triangles. This is going to be an important skill in I think you do a little bit of it in Calc 1 and a lot in Calc 2. Anyway, very, very common thing you do, especially in Calc 2. So let's draw a triangle. Basically, they're giving me the cosine. They're telling me what the cosine is. They're telling me I'm in quadrant 2. That's how I knew which quadrant I was in. And they want me to find the other 5 trig functions. All the rest. Now, it's not simple. Notice you can't just, the last problem, they gave me sine and cosine. So once I had both those, I could just whip out the others with just the simple definitions. But not so simple here. They're only giving me 1 trig function. Just from 1, you can find the others, but it's a little bit tricky. Yeah. I wonder if they want you to just...
That's 6 over R, right?
Yeah, right. Yeah, that's what I was going to do, too. And that's fine. That'll work all the time. Yeah, they'll probably show a different way here, but let's just do that. That's what we'll do all the time. Yeah, I'm going to make a little triangle. Right, here's the angle theta. And they're saying the cosine of that angle is 24 over 25. Is negative. Well, you know what? I'm probably... Just a second. I don't want to do something too early, so I'm going to change the game plan. Forget about all this. And I'm just going to use a simple theorem. Anybody know it? What is sine squared plus cosine squared? Yeah, do you remember that? That's what we're going to use. Later we'll draw triangles, probably like next week. But for now, let's just do sine squared plus cosine of any angle theta. Oh, sorry, I'm being kind of scribbly there. So sine squared of any angle theta plus cosine squared of that same angle adds up to be 1. That's an important theorem to put on your 3x5 card, really to put in your mind, because it's just used so much, so very much. Sine squared plus cosine squared is 1. Okay? So now, with that in mind, they're giving me the cosine, right? So I can find sine. Sine squared plus negative 24/25 squared is 1, right? Cosine squared. So, sine squared. Now, use your calculator. What's 24? 576? Yeah. What is it? 576 over 625 is 1. Good so far? So I'm running out of room, so I'm going to come up here. And now you got to solve. So you're going to have to subtract that from both sides. So so I have sine squared of theta plus 576 over 625 is 1. So subtract the 576 over 625 from both sides. Sine squared of theta equals, now how am I going to subtract those?
You're going to do 625 over 625.
Good. Yeah, the 1 here is 625 over 625. That's right. So sine squared is, what is that, 2449 over 625 when you subtract those. Then what do? We root it, right? Root it. Now, when you put a roof on the house, plus or minus, but it's not actually both. It's either plus or minus depending on the quadrant you're in. All students take calculus. We'll figure that out in a minute, right? So for now, let me just say 7 over 25. And then I'll put plus or minus. I don't know which sign it is. So the rooting canceled the squaring. So the sine of theta is plus or minus 7 over 25. Now, which quadrant are we in? Well, we're in quadrant 2. So in quadrant 2, what is sine? Remember the all students take calculus? I don't have room to write it anywhere. I'm going to come back up here. If you get that copied down, I hope. So coming up here. So we're in quadrant 2. All students take K. That tells you which ones are positive where. So sine is positive in the second quadrant. We're in the second quadrant. So sine's positive. So it's actually positive 7/25 for the sine. Does that make sense? So we've got the cosine. Now we've got the sine is positive 7/25. And we've had the cosine all along is negative. So once you have the sine and the cosine, you can get the other 4 no problem, right? Just by the properties. Tangent is sine over cosine, and away you go. Is that okay? Questions on that? So it was all about using sine squared plus cosine squared is 1. We're going to use that a lot. Let me go back to that again real quick, if that's okay. Sine squared plus cosine squared is 1. Why is it true? You know, I don't like things without reasons. Anybody know? Right? Just think about the unit circle. Remember what is the x coordinate of any point on the unit 1 circle? The x coordinate is cosine. The y coordinate is sine. Right? Which means over and up. Over is cosine. Up is sine. And this is 1 because it's a unit circle. Radius 1. So Pythagorean theorem, there you have it. Cosine squared plus sine squared is 1 because of the right angle in the Pythagorean theorem. So that's where it comes from. Sine squared, either order, you can switch the order on the sine and the cosine. Sine squared plus cosine squared is 1 because they're on the unit circle. They're the x and the y. All right, so everybody get that copy down? Did I go too quick? Questions on that one? So we have the cosine, we have the sine, now positive 7/25. We could get the other 4, no problem. Yeah?
Cosine is x over r. The
good question. Let's talk about that. Not quite. Part of what you're saying is true and part is not. That's a good question. Let me address it. Yeah, because that'll come up other times too. That's a really good question. I used to have exactly that same question. It's an excellent question. Oh, because I had it. No, I'm just kidding. I mean, it's a good question. It's an important question. Cosine is negative 24 over 25ths, okay? And the question being asked is, now Mr. Aaron, you said cosine is x over r, which I did. That's true. So then the x must be the 24 and the r must be the 25. Not true. How not true?
It is true.
How about not necessarily true? It might be true in this case.
Not in all cases, but it is in this case by definition. So I think it would make it true in every case by definition.
Okay, so to answer what I mean by not necessarily, what if I tell you, hey, I've got a rectangle. And it's a length to width ratio. Say the length is 10 and the width is 4, or vice versa, whatever. 10 and 4. I guess that's width to length, huh? So the width to length ratio. So think carefully about ratios and what they mean and what they don't mean. If I say, hey, it's 10 to 4, and somebody else says, and then and you say, I got a 10 to 4. Oh, actually, you know what? How would you reduce that? You would reduce that to be 5 halves, right? By top and bottom by 2. So really what people would say is they would say the width to length ratio is 5 to 2. But that doesn't mean the width is 5 and the length is 2. The width is actually 10 and the length is 4. You see, a ratio is not the same as an exact number value. It just means the fractions in that ratio, it may have reduced. You understand what I'm saying? In other words, whenever you look at a ratio, be careful. You cannot then imply individual numbers, right? When I say x over r is 24 over 25, that doesn't mean x is 24. This could be minus 48 over 50. X could be minus 48 and r could be 50. And they're still in the x over r ratio of minus 24 25ths. Do you see what I'm saying? A ratio does not imply individual numbers necessarily. So be careful about assuming that. All right. So, but there is a way you could do it with that, and you could set up triangles to do that. If you're interested, I can help you and show you, and we'll do that like next week. So I'm not denying that way works. That way can work. I'm just addressing that general idea of being careful with ratios. That'll come up again in calculus, that thought. You'll be tempted to think, well, if I got a ratio, I got the top and the bottom. Not necessarily. That could have been reduced. Whoop. All right, try that one. So they're giving you the cosine and then that kind of funny information. See if you can find the sine. It's going to be pretty much the same thing as last time, right? But a little different. Sine squared plus cosine squared is 1. Yeah, what quadrant is that? Pi is 180, and this is 270. If you plug in 180 for pi, right? This is pi, this is 3 pi over 2. So they're basically saying it's in quadrant 3. All students take, it's here, isn't it? That's quadrant 3. That is what they're telling you with that information. It's between 180 and 270. Between pi and 3 pi over 2. Not making sense? So can you find the sine then? Including the sine of the sine? Positive or negative, I mean. Get that part right also. Sine squared plus cosine squared. Like that. Like that. Like good. 25/64. And so then sine squared is 1 minus 25/64. Sine squared is, so that 1 is going to be 64/64. And what is that? 39? Is that right? 64th? And then root it. So the sine is the root of 39 over 8. The root has to stay on the 39 because you can't root 39, huh? But the root is gone from the bottom because I rooted the 64 to make 8, right? When the root does his job at the bottom, he vanishes from the bottom. Is it positive or negative?
Negative.
It's negative because third quadrant, right? All students take only tangent and his upside down cotan are positive in that third quadrant. Sine is not positive, he's negative. So sine is negative root 39 over 8. Everybody okay? I get a lot of mistakes with the root. Like people will vanish the root from the whole thing. Everybody clear on what that root on a fraction is? Remember those rules from algebra? When you have a root on a fraction, you try to root the top and try to root the bottom. When it tries to root the top, it can't, so it just stays there. When it roots the bottom, it makes it 8 and vanishes, right? When you root something, it leaves. Negative 39 over 8. Good there. And then you can get the other 4 trig functions same kind of way. Okay, so on this one, they're giving me secant is 8, cosecant's greater than 0. Find the sine. Let me give you a minute. Do a little creative work. See if you can find the sine there. That's what you can come up with. Our class tutor Roberto's here. Just like to point him out every now and then. In case you need help, 3 this week and 2 more. Crunch time, Roberto's there to help. Exam. When's our exam? Next Wednesday, Thursday, right? Exam number 4 next Wednesday, Thursday. Roberto's here early. I think he must have been 90 on the freeway.
No, it's Tuesday and Thursday, so I should have a little later.
From the other. Okay, I get confused. So, exam for Wednesday, Thursday next week. All right. So what do you do with this thing? So we want to use the sine squared plus cosine squared as 1, right? Here's my thinking. I'm thinking, okay, I want to use sine squared plus cosine squared as 1. But to do that, I've got to have either sine or cosine. What can you do with secant? What is secant? Yeah, it's the upside down of cosine. So that's basically saying 1 over cosine is 8. Secant. Secant is 1 over cosine. So that means cosine must be 1/8, huh? Does that make sense? So now put that in. So sine squared plus 1/8 squared is 1. Sine squared plus 1/64 is 1. Right? So that means, bring it up here. Sine squared is going to be, what's it going to be? 1 minus 1/64. Am I on the screen? Yeah. So sine squared is, what's that, 63/64? Good. Roof on the house, roof on the house. Sine is, the square root cannot root the top, but it does root the bottom, so it vanishes from the bottom. Is that positive or negative? Yeah, how do you know right away it's positive? Well, even if I don't find the quadrant, look at cosecant. What is cosecant? Cosecant's positive, greater than 0, and cosecant's just upside down of sine. So whatever cosecant is, sine is also. They're just upside down of each other. Their signs don't change. Right? So if cosecant is positive, so is sine. Without even worrying about what quadrant it's in. Sine has got to be positive. And now we can get the other 4. Is that okay? See, it's all about getting sine and cosine, and the other 4 will come from that easily. No questions? All right, because now the next one will need a different theorem. All right, so they're giving me tangent. Oh yeah, let me show the mistake that you could make if you weren't thinking clearly about that ratio thing I just talked about a few minutes ago. Somebody might look and go, look, it says tangent is minus 3 over 8, so that sine over cosine, I've seen this on tests a lot. And people go, oh, okay, so the sine is the negative 3, and the cosine is the 8. No, not true at all. But first off, sine can never be above 1 or below negative 1. I don't know if you know that from the graph. We'll get into that next week. But then that's not true at all. Now, so again, just because two things are on a ratio doesn't mean that those are individually their numbers, right? That has been reduced and changed, right? That's just their ratio. That doesn't mean sine is 3 and cosine is 8. So you can't do that, but I've seen that on tests quite a bit. So can't do that. That's not true. So, well, then what do we do? If we can't do that, how are we going to get sine and cosine? I mean, we have tangent. Pythagorean, yeah, the sine squared plus cosine squared equals 1. Yeah, let me write that. Sine squared, or let me put it over here. Sine squared plus cosine squared is 1. But how am I going to use that? I don't have sine or cosine.
Well, that's why you can just use the x squared plus y squared equals r squared, or a squared.
Oh, make the triangles?
Well, I mean, you don't
Totally.
have to make a triangle either. I mean, you can just actually just use the formula.
Yeah, you're right. You could totally do that.
Tangent is just the opposite over adjacent.
Right, so you can start doing that. And I probably would too, Robert. If you're good at that, just go do that. I haven't formally introduced opposite over hypotenuse and all that yet, so I'll just work with what but I know most of you guys already know that, and if you're good with that, go ahead and do all that. That's great. That's what I'll do in like a week or two as well, once I've formally gone there.
Are we going to be graphing too?
Yeah, next week. Do some, or maybe the week after. Pretty soon, we'll do some graphing. Just for Thea, because she tells me how much she loves graphing. Anyway, so what we'll do in this section, there's another theorem. Remember 1 plus the tangent squared is the secant squared? Do you remember that one? That one comes in real handy, and especially Calc 2 again. If you just start with this basic one, sine squared plus cosine squared is 1. If you just divide through by, that's supposed to say cosine, by cosine squared, just divide all the way across, then this, what's sine over cosine squared? Tangent squared. This is 1. And what's 1 over cosine squared? Secant squared. There's the other. That one comes in real handy. And it just comes from the basic one. Like I've always said a million times, I have bad memory, so I would just remember the main one. Sine squared plus cosine squared is 1, and I could just pick up the other one by just dividing through. So this one is used a lot, especially in Calc 2, a little bit in Calc 1. So you'd want to know that one. So tangent squared plus 1 is secant squared. So that's what we're going to use. How so? Well, now we've got the tangent right here. I'm going to plug in the tangent, and that's going to allow me to solve for secant. And then once I have secant, I can flip it. I have cosine. And once I have cosine, I'm off and running. Right? So let's do that. Everybody good to there? Can I erase some of this stuff? So this one's a little more tricky. Probably would be easier just to do the x over r stuff. All right, so we got tangent squared, so minus 3/8 squared plus 1 is secant squared. So that's what? 9/64 plus 1 is secant squared. Good to there. So now, what am I going to do with that? That one there is 64/64 again, huh? Add them up. What's this? 73. 64. Secant squared. Root it. Plus or minus, I don't know. So root 73 over 8 is secant. Plus or minus. Is it plus or is it minus? Oh, it says right here, huh? Secant's greater than 0. So it's just the plus. Secant is positive. So it's plus root 73 over 8. So we've got secant. If we flip that, we've got cosine, don't we? So I'm going to do that next. Are we good so far, though? So we've got secant. Everybody okay with how I got secant? Tangent squared plus 1 is secant squared. Okay. Now, we come up here again. And I'm going to use this to figure out cosine, huh? So I've got secant Secant is root 73 over 8, which means cosine is 8 over root 73. Now, of course, you need to get rid of the root from the bottom for typing it, but I'm going to leave it right now because it's easier to work with like this than it is to have more stuff involved. So, but when you type the answer, and you'd have to make it 8 root 73 over plane 73, right? When you multiply top and bottom by root 73, because you can't leave roots in the bottom. You all know about that. But I'm going to leave it like this for now because it's easier to work with it this way. It's simpler for the other steps that remain. Okay, so what other steps remain? I've got the cosine now. Well, there's a couple things you could do. You could plug that into sine squared plus cosine squared is 1 now. Would you prefer that? No, we could just do that. Or you could plug into now that you have tangent and cosine, you could solve for sine. That way also. I don't know what you prefer. I'll just go back to the normal. Sine squared plus cosine squared, plug that in. Cosine squared, so 8, whoops, not over 33, huh? 8 over root 73. Squared is 1. Like that. Yeah, Kelton.
Couldn't you just use 1 plus cotangent squared equals cosecant squared?
Mm-hmm. You could do that too. There's just a lot of things you could do. Yep. And so that would be, let me bring it up here. That would be sine squared plus, what's that, 64/73 is 1. Everybody good there? Squared the 8 and remove the root from the bottom. Subtract the 64/73 and you get sine squared. And that 1, again, you know the drill here. That 1 is 73/73. Subtract it. What does it say? 9/73. And then root it. So sine is 3 over the root. So is it plus or is it minus? Yeah, it must be minus. How we know? Couple ways. Tangent is negative, right? Remember from the beginning over here, it says tangent was negative. And so that means what quadrant? All students take calculus. Tangent is negative, and secant is positive. Cosine's, we already know cosine's positive, so it must be in this quadrant, huh? Cosine's positive, and in that quadrant, sine is not positive. Sine must be negative, so sine is negative. So I have cosine, I have sine. Now you can easily get the other 4. That good, Tim?
If you try to find sine using the tangent, you get negative.
As well, automatically just pops you out, because you don't have a squared piece.
Right.
You just go right to the sine. That's correct. So yeah, lots of ways. Is that good? So everybody see what I did there? It's all half erased now, but I basically plugged into tangent squared plus 1 is secant squared. And that gave me secant, and then I flipped it to get cosine, and then I plugged into sine squared plus cosine squared is 1. Fair bit of work there. No questions? We all good? Even odd properties. So what are they talking about? A couple things. Do you remember if you have what's called an even? It's been a while. We did even functions maybe a couple months ago. It's been a while. Basically, if you have an even function, what that means is if you have a negative whatever plugged in, negative theta, negative x, whatever, that you can just ignore the negative. And if you have an odd function, what that means is if you plug a negative inside, it has to go to the front. You can take it to the front. So odd, pull, whoops, I can't write with my finger. It's finger painting day here. Pull negative to the front for odd. And for even, ignore it or cancel the negative for even. So for even functions, you can just ignore the negative when it's plugged in. And for odd functions, you pull the negative to the front when the negative is plugged in. So again, in both cases, it's a way to deal with a negative plugged in. Either ignore it or pull it to the front. Now, what do we mean by even functions? Even function would be something like x squared. Even power. That's where we get the name, even powers, you know? Like x squared. You know that's true, huh? If I plug like a negative 3 in there, what happens to negative 3 squared? The negative just vanishes, huh? Just goes away. Whereas what if I odd function would be like x to the third power? What happens if I plug like a negative 2 in there? The answer comes out negative because it's odd, huh? So that's where we're getting the idea. Well, it turns out sine and cosine and tangent and all the rest are either even or odd and thus share these properties. Anybody happen to remember what they are? I would be impressed with your memory. It's way better than mine. I would know if I didn't teach this stuff day and night.
Cosine and reciprocal are the only ones that are even.
Good job. Exactly right. Cosine and his reciprocal secant are even. The rest are odd. Sine and cosecant and tangent and cotangent are all odd. Yep. So you can put that in your 3x5 card. I wouldn't memorize that. That's not something you're going to use in calculus hardly at all. It's really not a big deal. Just put it on your 3x5 card. Sine and cosecant, tangent and cotangent are odd. And yeah, the way Robert said it is a good way to remember. That's how I remember it too. I just remember only cosine and his reciprocal are even. Notice how functions always go with their reciprocal when it comes to the properties. They always share the same properties. So that way you can just remember cosine. Only cosine's even. And of course his reciprocal. And the other one, sine and tangent, and of course their reciprocals are odd. That's probably how I remember. Cosine is even. Cosine is even. So what? Cosine is even. Or actually, well, they're asking me about cotan, aren't they? So cotan's over here in the odd category. So what does all that mean? Cotan is odd. Let me erase this. And let's do something about it after all that theory talking. So what? Cotan is odd. What does that mean? When you're odd, what can I do? What does it say over here that you do with the negative for an odd function like cotangent? Pull it to the front. So that means it's negative cotan of regular 60. It's not a big savings. I mean, it isn't like it's the biggest, greatest, fanciest thing in the world. It just means you never need to deal with negative angles. If you know the properties, then you never need to deal with negative angles because you can either ignore the negative for even function like cosine, or you can pull the negative to the front for odd functions like the other ones. So either way, you no longer have a negative in the degree. It's either at the front or gone completely. It's not the greatest savings in the world. I mean, it's not the end of the world to deal with a negative angle. But anyway, there it is. So that's what it means. It just means we still have to do the rest of the work. I mean, it isn't like it's automatically done or something. It's just now you can just deal with a positive angle instead of a negative. So I would still need to find what is the cotan of 60 degrees. So I would need to go to my unit circle. 60 degrees is up here, huh? There's 60 degrees. And so that's over small up large, huh? Over small up large. So it's over a half up root 3 over 2. And cotan, remember, is cosine over sine. You got to put the negative. Negative cosine over sine. So negative cosine is x, sine is y. Negative a half over root 3 over 2. We good there? And then you know the drill. Flip that up. So I'm running out of room here. So that's negative a half times 2 over root 3. The 2's cancel. Negative 1 over root 3. There we go. I suppose I better get rid of the root from the bottom. Multiply top and bottom by root 3. Negative root 3 over plane 3. There is the cotangent. So I just did the cotan of 60 and I threw a negative in the front. So it's not that much new. Questions on that? That makes sense? So only cosine is even, the other ones are negative, or are odd. Have a good day. So this 6.3 is not due tomorrow. We didn't quite finish it.